work kind of job.
All right. Not chemistry, calc 62. Okay, so work is force times distance. Your homework's to do A and B.
Okay.
Okay. So force times distance. Unfortunately, if the force is, or fortunately, if the force is constant and the distance is constant, then that's super easy. But forces usually change, right? Like nothing pushes on anything for the same amount of, like with the same amount of force consistently, except for like gravity and stuff. But most forces are variable. And so in calculus, and work is the same as energy, by the way. So that is energy. So if I want to find how much energy is used with like a force that's pushing on something or whatnot, I will use calculus. So here's the idea. We will have a function that gives us the graph of force over some distance. Let's say this is our function. Okay? Now, if the force was constant, then I would just multiply force times distance and be done. But if the force is changing based on the distance, then I can't just multiply them. I must integrate them. Why? Because I'm going to multiply the force, which would be the y value, times the distance. But since the force is changing, I'm going to add an infinitesimal slice of force times an infinitesimal dx distance and add all of those up. Does that make sense? If force was constant, if it was a number, then I would just multiply that number times the distance. But since force is changing, I have to add up all of these forces times super small distances and add them all up. How do I do that? Well, that's what the integral does. So your dx is your distance. A and B are your starting and ending points, and you're going to integrate over that. So let's try a couple examples, and you'll see that this is super easy. A steady force of 50 newtons is applied to an object to move it 100 meters. Okay? So force, in this case, is 50. The distance, or change in x, is 100 meters. What's work? Force times distance. But we're going to use our integral form. So from 0 to 100 meters, dx. What is my force? 50. So I'm going to integrate 50. What's the integral of 50? 50x. Right? Integral of a constant, you just add the x in your set. We're going to integrate from 0 to 100. So that's 50 times 100 minus 50 times 0, which is 5,000 Newton meters. Okay, now what if the force is changing? Well, they're going to give you the function for force. So if we have a force that is 1/2 x squared, and I am exerting that force from 0 to 6, what's the work done? Work is integral of force dx from 0 to 6. What's my force? 1/2 x squared. And I'll integrate that. What's the integral of 1/2 x squared?
1/2 x.
Add 1 to the power, divide by that. Add 1 to the power,
X cubed.
divide by that number.
Oh, divide by 3.
And then we have the 1/2. So it's x cubed over 6.
Yes.
Integral, you add 1 to the power and divide by that number. Derivative, you bring the power down.
Okay.
0 to 6. So 6 cubed is whatever 6 cubed is. That's gross. All right, I'm going to be lazy because I know it's over 6, so that's 36. Okay, what are my units? Generally, either Newton meters or joules. Joule, which is a Newton meter. Okay, that's your lesson.